Yeah, the title of the presentation is Archaeological and Environmental Assessment Supported by Inspire Invoke Spatial Data Services. My name is Anna Halvarsson. I work for a state-owned company from Sweden named Metria that work within the field of geographical information and geographical information technology. Let's get back to this one. I'm working up in the very far northern parts of Sweden in a town called Luleå. We're only about 100 kilometers from the Arctic Circle. And normally I start my presentations with something that is kind of an image that illustrates the season. And this year we are growing strawberries. And you might think that strawberries would be very hard to grow up in this northern part of Sweden, but I tell you a secret, that is actually the best parts in Sweden to grow strawberries, because nowadays we have, when it's summer, it never gets dark, so you get the best berries in the country up there. Let's move on. I'm very glad to do this presentation together with Dean Hintz from Safe Software. We had some problems with our presentation, so these X's, they really say that he's working with XML. He's a senior analyst at SAFE, working with SDI implementations, raster, and of course XML. Up until now, I think the main focus for the Inspire implementations has been on the data producers, and for them how to cope with all these things that Inspire says that they have to do to be able to actually make their data available, searchable through metadata, and produce the view and download services. And we have quite a lot of services out there now that we can start to use. But maybe, and I think some of the other speakers has been talking about this as well, that maybe it's time that we start to switch focus to the data consumers, the one who actually has to work with this data if we want to get the data services that can be invoked. Because here we saw, oh, maybe this can be one way to take a step towards the user side of Inspire. So I borrowed this image from that document, and this just tries to explain that what is an invoke service. Well, it's just actually a web service where you use one or many other services be able to do something that combines data. And finally, also these spatial data services will be made available and made discoverable through metadata, etc. The project that I'm going to talk a little bit more about today was actually introduced to us by the Swedish Transport Administration in Sweden. They are the largest purchasers of archaeological excavations in Sweden. Each year they invest approximately 20 million euros in different archaeological projects, because when you want to start to build a new road or a new railroad, you have to consider these things. You aren't allowed to just go on and dig and build your road wherever you like. But you actually have to consider these archaeological findings that can be out there. And one very big challenge for them is that it's very difficult to predict the cost of archaeological excavations. And they saw, when they started to look into this, they saw that one project could differ a lot from another project. So the question was, is it possible to predict the costs for areas that are not yet investigated. So they made a decision that we would start a research pilot study, and the project was named Särimner, after the pig in the Nordic mythology that was killed every night but came back every morning even bigger and fatter than the day before. So I think they hope that this project will come out the same way. You work with something one day, and then when you came back the next day, it can only get better. So the people that has been involved in this project is Maria Hallersjö from the Swedish Transport Administration, Erik Lundborg from Metria, and Ingela Spikeman from a company named Vectura, who is an expert within the archaeological field. They also work together with universities and a couple of other governmental agencies. What you really want to do is that you like to combine past and present. And one thing in Sweden is that the country is very affected by the great ice. And the land evaluation is approximately 1 centimeter per year. So the Swedish Geological Survey has calculated the historical shoreline. And I will show you in a couple of slides how we have used that one. So today, this is basically the kind of maps that are available when you work with these questions. You have some kind of background map, and those black dots that you see are archaeological objects that are known today. But within this pilot project, one thing that they have investigated is what kind of data can be used in order to find out where there has been different kind of historical human activities. So Sweden has a new terrain model, and this image just shows how we use the terrain model and had added the archaeological objects. And the archaeological objects are read here as in WMS. They are also available as a WFS. This is when it starts to get interesting. When we add the historical water level that shows us where was it water 2,500 years ago. And pretty soon we have a rather clear pattern where we can see that the archaeological findings and the archaeological objects, they are normally close to the water, but almost never within the water, because there people didn't live. They used it for fishing, and they lived close to the shoreline. So within this pilot project, one of the main reasons was to see is this possible? Can we use Spatial Services for this? So the test case was narrowed down to a question just to try to find existing archaeological findings and protected sites within a specified distance of a road network. And the result of this was a PDF showing a result. And this is where Dean will take over and talk a little bit more about how this was done.
Okay. So, not sure where I'm pointing this. Okay, and this is just a slide showing the various web services that were used to feed this. So as Anna mentioned, the Swedish Transport Administration, they have a WFS that provides the road networks that are going to be selected for evaluation. And then we get the protected sites from the Environmental Protection Agency and the archaeological objects from the National Heritage Board. And the test environment, it's using FME version 2012, sort of the latest and greatest, and FME server. And then there's various Inspire services. You have to think about this, that it's a bit of a, as Anna mentioned, it's a bit of a perspective shift that we always think about the WFS or the OGC services as somehow the output of our system. But really, what we're trying to communicate here is that those really are just building blocks that we can then synthesize new services that ultimately that are customized to what the end users need. So I'll just go through the transformation workspace. So you can think of this as the ETL process. It could be done theoretically in any environment, happen to be using FME in this case. So there you can see the inputs. Got the road links for WFS. So these are all basically 3 different WFSs. And what we do, first of all, is we use the spatial relation. So we have to actually reproject the data to get it in the same spatial frame, and then find all of the archaeological points and protected sites that are within a buffer of those road links. And then once we've found the objects of interest, then we need to do a schema mapping, because we don't need the entire Inspire schema in the output data. The consumers of this, the planners that are doing the evaluation, they're mostly interested in maybe some object type and name information. And then we need to style the output and write it out to separate PDFs. And so this is what the workspace looks like. So you can see the 3 different data sources, the three source WFS is on the left, and the transformation process, buffering, spatial relation, and then those are the output PDFs on the right. And this is just an example, snapshot of inside one of the schema mapping transformers. Here you have the relatively complex Inspire schema and a fairly simple output schema for the PDFs. And the point here is not to complain about the complexity of Inspire. Inspire is complex for a very specific reason, because it has to capture the richness of the data that we want to share. The point is that we can take a snapshot of that data that's only needed for this specific application and present it in a PDF that's very easy for the planners to consume. So I'll just a couple words about FME in general. Everybody knows about FME support for format translation, but we're really focusing on things like schema mapping and data validation to support Inspire, as well as we treat XML and web services as just another format. And ultimately, we believe FME Server is a good platform for invoke services, where you can synthesize existing Inspire OGC services and then present them in a way that any client can access, even a mobile phone. And the way I like to end off with is that really I believe Inspire will only be truly successful when most of the people using it don't know they're using it. Those of us in this room, we all know a fair bit about Inspire, more than our neighbors down the street. But really, when somebody picks up their mobile, or a planner in his office who has never been to one of these conferences asks a question of a system, he doesn't need to know what's going on in the background, all the queries that are happening. But when he benefits from the Inspire information, then we've been successful. So, Anna, do you want to wrap up?
So this is one of the results that we did get back, and if you're interested to take a look at the output PDFs, you're welcome to come and visit us in our booth. We will not have time for that now. Still, I think PDF is a very, very good format when you have a user that is not a GIS user, but you can still get a whole lot of information passed on to the decision maker. I'll just give you a very quick example of a future analyze where we will be able to add information about the historic water level and be able to say that, okay, within these yellow areas with the water, then we won't have to do archaeological survey. And within the orange areas, it's likely that we will have more findings. One thing that you have to know is that, of course, Inspire is it's a work that is in progress. Services start to be in place, but there is still a lot of work to do. And as Dean said, sometimes there can be complex data schemas, but I think the way we have worked with FME to solve this, we have made a very easy way to even to cope with that kind of problems. It's also important to remember that we have to work between the domain specialists and the technical experts to be able to see the patterns and find good solutions. The experience from this project was that to create mashups or invoke services, it works very well, and it's easy to mix services with local data, and that FME is a really good environment for this. But you must also be aware of that when you're using services from different service providers, you are very dependent on the services, and it's important to be sure that the services are up and running when you need them. Yeah. So, what are the next steps? Of course, there's a whole lot of work left to do before this can be finished. But during 2012, there will be reports on the results to the, and also we will have a workshop for the Swedish Transport Administration. And we will make decisions on which technologies we will use in the further development. During 2013, the plan is to start to build a web environment based upon the chosen technical components from the pilot study. So, but we hope that the project will be as fruitful as hopefully my strawberry plants will be. And by that, I just want to say thank you. And
I'd like to thank the speakers because we're virtually on time. So what I'd now like to do is throw it open for maybe a few minutes of questions. So if anybody has got any questions they would like to pose to any of the speakers up here, please just put up your hand. Yes, right in the front.
Thank you very much. I have a question to Mr. Salvamini. As generally known, there are a number of countries who finished their e-government infrastructure already. And so did Turkey as well, through the public company Turksat, which I am working at. And my question is, which challenges do you think we are likely to face when integrating geospatial information into e-government infrastructure, which basically based on non-geospatial information? Thank you.
It's a good question. It's a good question. Difficult to answer. I can tell you that since the geographic information is starting now to fully enter inside the e-government, we have to deal with the future solutions. There are some good opportunities because people, users, and also administrations are aware day after day that geographic information, location is very important. This is very good. This is a very, very good opportunity. On the other hand, there is the problem, which is a problem, is that the geographic information at national and also at subnational level are managed by a small number of offices. Very often, one office is managing geographic information. So this is a very critical point, because the issue is how to integrate the competence of this and the labor and the effort of this office, generally speaking, generally is one or two of them, within a very large and huge system, which is the e-government. So in the future, public administrations will be called to manage this integration process between few people, experts within themselves in the public administration about geographic information, and the large number of people, of employees who are already experts in e-governments and in providing services through the e-government. So there are good opportunities, difficulties, and is to us as solution providers, of course, methodological solutions. I'm not speaking about technical solutions. I'm speaking about solutions in terms of methods, in terms of systems, in terms of organizations.
Thank you, Mauro. In about 5 minutes' time, the next session will start, and we, I think, all do need a bit of a break.